Yes, nakusikia. Hello?
Hello.
Nakusikia.
Hello. Good evening.
Good evening to you.
Okay. Caleb,
Evening to you.
Michael,
Evening to you, sir.
Kipto, Kipto. Where are you? Philip.
Yes, I'm present.
Okay. Welcome to our class. Today, today we are going to look at induction motors. Are we there? Can you see my screen?
Yes, we can see your screen, sir.
Yeah. Caleb, can you tell us what is on the screen right now?
It is induction motors.
Okay. Very nice. Today, that's our lesson, and we have only two objectives. And by the end of this session, you should be able to describe the construction of induction motors, and then you calculate the synchronous speed of induction motors. So to start with, let me display first of all that is the induction motor which is opened. Can I share it fully so that everybody can see it clearly? Are you able
It
to
is
see?
clear. You're able to see it clearly.
Is it large enough?
It is large enough
Yeah.
to me.
Though on my side it is not updating very well. I think it is. Philip, can you see it? Philip, Philip. Okay, let's continue. That's how an induction motor looks like, and you can see there are various parts, and we're going to look at them now. Maybe just to ask, Serem, Serem. Okay, so on the introduction, so we'll talk about the three-phase induction motors are the most common and frequently used. They have various characteristics, and as you can see from the screen, they are usually simple in design. They are rugged, meaning they are strong. They are cheaper, that's low price, easy to maintain. They range between, they have a wide range of power ratings, that's a fraction horsepower, to 10 megawatts. They usually run at a constant speed from null to full load. Those are various characteristics of the uh, three-phase induction motors. And as you can see, its speed depends on the frequency of the power source. For example, if you have connected your motor at a frequency of 50 hertz, it will run at a speed of 50 hertz, unless there is what you call the sleep. Now let's see. Let's see the construction of the induction motor. So we usually say that an induction motor has two main parts. There is a part which is stationary, and there's another part which is movable. The stationary part is called Caliph. Caliph.
Yeah, we
Caliph.
have a station. Yes, sir.
There is an induction motor has two main parts, isn't it?
Yes.
Which one and which one?
There is a stationary part
Uh-huh.
and there is a movable part.
Okay. The stationary part is called
Pardon?
the stationary part. What do you call it?
It consists of frames,
Okay.
support hollow cylinders,
Mm-hmm.
top. Yeah.
So it is the stator. Philip,
It's,
what do we call the part that is movable? The rotating part of the induction motor.
what is called the rotor.
Okay, the rotor. Very nice. So, as you can see, that is the stator, and that is another part is the rotor, which which is composed of punched laminations, which are structured to create series of rotor slots. And there are two main types of rotor. Serem, can you tell us the two types of rotors we have? Serem, Serem with us? I hope you can see on my display. We have what called this one. What do we call it? Caleb?
That's a squirrel cage rotor,
Yes.
and you have a wood rotor.
Yeah, we have the wound rotor and the squirrel cage rotor. Those are the two main types of rotor. We are going to look at it deep about their characteristics and the differences. We are going to look at them later. So when you go to the main construction, you can see we have various parts. Can you see my mouse where my mouse is moving? Can you see my mouse?
See your mouse.
It's rotating on somewhere, isn't it? So there are various parts. You can see we have this is the main frame. These are the cables which supplies the power. We have the brushes. We have the slip rings. Then we have so many, but this is the rotor. This is the stator. This is the handle for lifting. Yeah. So that is basically the major parts of the induction motor. And you should be able to list all the parts of the induction motor. And that is as per our objective number one. That is describe the construction of induction motors. Then when we go to the other part of the induction motor, there is what we call the synchronous speed of the induction motor. And whenever we supply the induction motor with the power, there is a what is produced what we call the rotating magnetic field. And this rotating magnetic field in a balanced three-phase windings is what produces what? The synchronous speed. As you can see, this formula is what is used to calculate the synchronous speed. Can you see my I have made it wide for you to see. This is the formula whereby the synchronous speed is equal to 120. 120, this is the angle of displacement between the windings. And it is not the mechanical angle, it is the electrical angle. Then this is the supply frequency, and P is the number of poles, as you can see from the description here. So, uh, from the formula, if for example you can see P is the number of poles. This is the supply frequency of 50 hertz, and this supply frequency of 60 hertz. If the motor has two poles, then its synchronous speed will be 3000 revolutions per minute, or RPM. If it is 60, it will be 3600 from this formula. Okay? Any question from there? Caleb, any question?
No, I don't have any question.
Okay, Philip, any question?
I uh I don't I don't have any question.
Okay.
Yes.
Yeah, so basically, if you want to calculate the synchronous speed, and you've been given the supply frequency, and you've been given the number of poles, you can easily calculate the what? The synchronous speed of that induction motor. So, for example, if the motor is 12 pole and its a supply frequency is at 50 hertz, you can calculate from the formula. It will give you 500 revolutions per minute. So the more the number of poles, the slower the motor. And then our last part is just to look at the waveforms of the rotating magnetic flux or the field. Simply because you can see the red phase, the yellow phase, and the blue phase. This is just for to understand how we are going to understand the rotating magnetic flux.
Can I
So
start?
yes, Caleb, you seem to have a question.
Yes, so you recommend for a two-pole motor instead of a 12-pole. Origin is effective.
Oh,
Assuming you want to work for a client, which one would you recommend?
okay.
A
Uh,
two-pole, 12-pole.
what I can recommend is it depends on the purpose of the machine. If the machine is used for high speed, I recommend it will be automatically for using it will be a lower number of poles, and it must be even number. But if the machine is used for low speed, it will be automatically be of more number of poles. So this number of poles, the torque which will be developed will be the same. Either the machine is as a high speed or low speed. So the what is required is the purpose of the machine. If it is for high speed, use the high speed machine. So I think we can conclude our lesson at that point, and I hope you have a nice evening, isn't it?
Okay.
Thank you for joining my
Yes,
class, and have a nice evening. Thank you.